Hey, hi everyone. Good evening. Good evening, everyone. Welcome to Cat Ninjas. Welcome to Cat Ninjas. Let's continue our journey with reminders. So we'll continue from where we left yesterday. Yeah, of course, there is much to say, but then yes. So if you have gone through this class course structure, you kind of know what we are getting into. Great. All right. Give me a quick understanding on the audio and the video, then we will get started. So if it is all good, I'm hoping things are fine. Good evening, everyone. I hope everyone is doing good. Things are pretty okay. Has the streaming started? Okay, it looks we are live. Yeah. Okay. FFRA is confirming. Sarthak is confirming. Okay, there is somebody by name Army here. Okay. All right. Hello. Yeah. Ramakrishnan. Hello. Hello, Suraj. All right, fine. So you're all confirming that things are fine. So let's get started. Then, all right, if everything is good, let's get started. Meanwhile, you guys settle down with your book, pen, paper, all that is important there. So here I am, a Belvi Srinivas. I've been working in this industry since 2007. That's about 14 years now, in various capacities, both in terms of management as well as in terms of training. Yes, in the 14 years, I also developed a good amount of understanding as to how to train students in a methodical way so that they go on to achieve very high scores. And also, I'm expert in counseling as well, so I give suggestions to improve the scores, select the right kind of B schools based on my own understanding from the experience. Yeah, so here you are. So if you'd like to interface with me for a quick understanding, so this is the Telegram channel. You can note this down, may not be right now, so you can put it down maybe at the end of the video. You can come back and you can note down the channel, and you can join this particular channel for short understanding of few things. So all the notifications, whatever the programs I do, different kind of courses that I carry out, all the notifications will be put on this particular channel, so you can also join in here. Yes, that's pretty much about short description. Yeah, so let me quickly finish the basic understanding about what Unacademy offers. Unacademy offers two kinds of courses, as you all might aware. So one is a plus, the other one is a star. It is not star, in fact, it is iconic. Yeah, plus offers you all kind of structured courses, right? Structured in the sense it could be with respect to the lectures, or it could be with respect to the weekly test. So everything comes in a much structured fashion. So what we are doing on the YouTube can be sometimes a little unstructured here and there. You might have to figure out your own schedules, etc. Whereas Iconic, in addition to all the structured courses, this plus, in addition to this, you get a lot of one-to-one counseling, in the sense like you can always set up a one-to-one meeting with one of your choice mentors, and you can figure out your test analysis, how to improve those extra 10 marks in the section or extra 20 marks in a section. What should be your study plan? Or its study plan can be with respect to the CAT, or it respect to GMAT, or it can be with respect to your interviews. All of it can be figured out, because it can be different from different people based on the time talents that is available that they possess. Basically, that's what I mean, right? So all of that, and the B school guidance, the SOPs, all that stuff. So that's what Iconic gives you, a lot of one-to-one interface. The plus subscription, these are the subscription, this is the subscription fee. So these are the on the face of it, this is the fees. On this, you will get a flat 10% discount by using an educator code. You can use Belvi 100, you are free to use. And if you're looking at CAT 21, CAT 22, CAT 23, these are the three kind of subscriptions which can suit the individuals. Iconic subscription, yes, appears to be a little premium, because it comes with a lot of one-to-one interface, and this is most suitable for CAT 21, right? So most suitable for CAT 21, because you might have to speak to a couple of mentors. It's very important, be it with respect to prep, be it with respect to your B schools, what to write, what not to write in the forms, because B school forms come with loads of questions, and based on those questions, sometimes your interview takes the direction. So therefore, what has to be written, what need not be written, based on what you have written, how you need to prep. All such guidance may require one-to-one interaction. That's what this does. Yeah, and this is for CAT 22, suitable for CAT 23, etc. Fair enough. So that kind of brings us to the end. Last slide before we get on to the lecture. Yeah, the prices may go up by mid of this particular month. So if you are making any choice decision, so make it little before, you don't have to pay any additional premium there. Right. All right. That brings us to the end of the announcements. So before we start, all right, Kalpit, yes, Kalpit, that's right. That's right. I'll be launching by mid because I'm little held up, right? The reason I'm delaying is I'm little held up till about 18th or 19th of this particular month. I have very limited window, right? Yeah. So after 19th of month, I will have more window where I'll be launching batches on the plus. Maybe bit of the individual batches that gives me a bit of flexibility there. So once I am more on the plus, probably I will reduce the time on the YouTube. That balance will come. So yes, so if you are asking, so Kalpit, if you are asking, yes, I'm little held up till here. So I will not launch till that particular date. After that date, yes, I will be launching for sure. Right? Definitely I'll be launching the batch. One for CAT 21, one for CAT 22. That answers your question, Kalpit. Yeah, yeah, good. All right, perfect. There we are. All right, so let's get started from where we did. And if you are listening to the lecture for the first time, and if you have kind of, I mean, like, if you're doing the remainders right here, and if you have not done yesterday's lecture, I would rather suggest so you follow this, but then you do that particular lecture as well, because I'll be drawing little bit of now I will be using some of those concepts what we discussed yesterday into this particular lecture as well. Right, so that's what we do. Let's examine today the Fermat's theorem. We'll examine this particular theorem and we will do the application built on this particular theorem. So yesterday I said that, okay, so it's not over yet because I can speak about it for another 1 hour, because yesterday we talked about preferred remainders being 1 or minus 1. The preferred remainders 2 and minus 2 exist. Preferred remainders 3, minus 3 exist. Preferred remainders 4, minus 4 exist. Preferred remainders 5, minus 5 exist. I am not touching this space because that takes a lot of our time. So but then I spoke about this, I gave the hint on this, how to work on this. Based on certain remainders, the questions can be solved by using 2 minus 2, 3 minus 3, 4 minus 4, and 5 minus 5. I'm taking a skip on that because of paucity on time, right? So therefore, because I'm doing only a little bit of impactful topics out here, so therefore I'll let you know. So we are going into the next one, which is the solid Fermat's theorem. Fermat's theorem is what we kind of look at, right? So 1 and minus 1 is the preferred remainder I demonstrated yesterday, right? Yeah, I'm not demonstrating these features because that will take another one full clip. So by the time I demonstrate, if not at least 30 minutes is required, I'm not spending that time. I'm giving that hint that, hey, these are also it's what we can do. You may have to kind of think on that, right? Yeah. Shashwat, that was the answer. 25 raised to power 36 mod 601. The remainder one. That's correct. That's correct. That's correct. I hope all of you would have got that particular answer there, yesterday's lecture. So yes, so let's continue the Fermat's theorem. So if it is required, we will solve that question at a later stage. But I think yesterday's question, Shashwat was reminding, yesterday we had a question 25 raised to power 36 when divided by 601. The answer is 1. That's correct. Answer 1 is correct. Right? Answer 1 is correct. That's the right answer. So I'm hoping that everybody got that answer. Let's get on to today's lecture. If required, we'll come back to this. Let's examine how we got this. At a later stage, we will do that. Let's not hurry into it. It's a very simple question. Yeah, fair enough. Let's take a look at this. Let's take a look at this. What does the Fermat's theorem do? So again, divisor is important. What is that? We generally write. So if this is the number, this is the divisor, this is the number, and this is the divisor, this is the divisor, and here comes the remainder, right? So that's how the format that we have decided to write. It is not numerator denominator. Fair enough. So the divisor, already in a Fermat's theorem, the divisor should be a prime number. All right, of course, there are again 3, 4, 5, 6 different models in this. There are again in the Fermat's theorem, once you understand it, there are 3 to 4 kind of questions that we have. We'll try and illustrate all those 4 types or 5 types as we go along. right? Yeah. So first let's understand the theorem so that it's easy to use it. Yeah. So divisor has to be a prime number. What if it is not a prime number? We may not be able to apply this particular theorem, right? So we may have to think of some other theorem. So what about the number? The number should be of the form, there should be some base. We talked that number will be of the form a raised to power b. But the Fermat's theorem may not understand what is this b. It says that if the power is of the form p minus 1, then the remainder becomes 1. Right. So why we are talking about this particular theorem? Because we said that our first preferred remainders are 1 or minus 1. Therefore, we are learning a couple of theorems which gives us 1 or minus 1. So that's the whole idea of this particular learning. Let's do this once again. See, how do you look at this? First, you have to look at the divisor. Divisor should be a prime number. I'm telling you how to look. You don't look number first. There is a way to look at this. First, you've got to look at the divisor. If the divisor is a prime number, then you look at the base of the number, only the base of the number. The base of the number. Your number is of the form a raised to power b. It's an exponential number. But look only the base of that particular number. They both should be co-primes to each other. Every time, whenever you look at something, you are examining some parameter. You are not simply looking just for the sake of looking. No, you are looking with some interest, which means you are looking with some purpose, right? Okay. So what is that you are looking first? You look at the divisor and you say that yes, it's a prime number. Then you look at the base of your number, because we use this theorem for the exponential number. You look at the base of the number and then you ask a question: are these two fellows co-primes to each other? What do you mean by co-primes? The HCF of the given number should be 1. HCF of a comma p should be equal to 1. That's when we say that the numbers are said to be co-primes to each other. That's the purpose. Whenever you see something, that's what you do. Then what you do is you don't look at the power at all. You don't look at the power. Instead, you say that had it been p minus 1, had it been p minus 1, which means this, where is that p here? P is the divisor, which is a prime number. 1 less than that particular prime number. Had it been p minus 1, the remainder becomes 1. You can write this. This is the assurance. All right, this gives this particular assurance, saying that in this case, the remainder would be 1. That is the pattern of understanding this. Then we will see that, okay, what if it is not p minus 1? Because it is b. B need not be p minus 1. Correct. We know about it. So we'll understand that how do we reach there. Therefore, how do we reach b? We will see that. Let me illustrate this. For example, let me take the divisor as 5. Let me take the divisor as 5. Write anything which is co-prime to this. For example, is 2 co-prime to this? Yes. Raise it to the power 4, because if you are seeing 5 here, 1 less than 5 is 4. This gives a remainder of 1. We can check this. Why I took 5? Because it's a simple number. Simple number. We can check this because I don't want to prove it, all that stuff. Rather, just examine that this is what is happening. 2 power 4 is this. All right. So next one, all right, now let's say that, okay, let's keep till 5 here. What if I write another number which is co-prime to this? Shall I say 3 is co-prime to 5? Yes, 3 is co-prime. So therefore, again, if it is 5 here, write 1 less than 5, which is 4. The remainder becomes 1. You can examine that. Okay, should I be writing it less only? Absolutely not. Can I write 7 here? Right, write anything which is co-prime to this. Raise it to the power 4. The remainder becomes 1. For example, I have 19. Okay. All right. Now then you will write all right something called as 27. Is 27 co-prime to this? Yes. So all the theorem says is raise it to the power 18. The remainder will definitely become 1. Definitely it would become 1. Fair enough. This is what this particular theorem is about. Let me illustrate this by using a simple example. Then we will open up to the application. There are 3 to 4 models here, 3 to 4 types of questions. We'll go to all 3 to 4 types of questions and see how we can solve them faster. So before that, let me illustrate by taking a simple, very, very simple example. For example, I have a question, let's say 2 raised to power 100 when divided by, say, when divided by 13, what is, when divided by, say, 19, what is the remainder? 2 raised to power 100 when divided by 19, what is the remainder? Listen to me, 11th standard math. Technically, this particular theorem is taught in 11th standard. So therefore, those who have not taken math during the 11th standard might appear little jittery. It might appear because otherwise most of the concepts are till 10th. It is very easy to teach most of the concepts in CAT, except few concepts which you study in 11th, right? So some of them, AM greater than or equal to GM, applications built on AM greater than GM, HM. CAT questions come in this. Sometimes the geometry questions can be asked on this. Sometimes arithmetic questions, fuel efficiency, what can be the maximum fuel efficiency, AM, GM works faster, right? So this concept comes, but this concept you generally study in the 11th standard. Sometimes you study sequences and series. You have this 1 into 3 into 5 into 7 into 9 plus 1 divided by 5 into 7 into 9 into 11 plus like this. All right, now so like this you write it till about 31 into 33 into 35 into 37. In fact, this was my CAT question. My CAT question means I got this question in CAT, right? I got this question in CAT in 2016 or 2017, one of the slots. This was the thing. Hey, what is the sum of this? There was some huge number which was written there, right? So something divided by something, some question was there, some numerator by denominator was given. Sure, calculator can also be used, no problem. But this is what the pattern was, right? So where do you study this? This you study in the 11th standard. Sequences and series of this particular nature, which came in CAT, you kind of study in the 11th standard, no doubt about it. Therefore, I say that, hey, there is some portion of it 11th standard. No mention of 12th standard I have seen, because 12th standard is more to do with the calculus. Any board, the entire 12th is limits, continuity, and calculus. That's the differentiation, integration. Most of the focus goes on that. So a little bit of algebra is technically dealt in the 11th standard, some portion of it, because you see, you do vector algebra there, you do matrices, you do determinants. I don't use all of that. You do inverse trigonometric function. Of course, you do trigonometry. And along with that, you do a lot of inverse trigonometric function. You do conic section in 11th standard. All that is not required. Conics, hyperbola, etc., etc. May not be required for me. A small portion of 11th standard is essential. Yes, all right, that is essential. So that portion we take. So that how much is that 11th standard? Maybe 20% of 11th standard is required for CAT. Yeah, that's the point there. Any which ways, let me come back to this. So I am going little slow in this. Is some topics I have to go slow because that is from the 11th. There may be some audience who might not have done 11th math. All right, that's where the problem may come. This is one of the 11th standard subjects. What I'm trying to do. Fair enough. Very simple though, not big deal. 2 raised to power 100 when divided by 19. What is the remainder? What do you do? So you again, you go by saying that I know that. I know that. I don't know how many of you have written. I used to write in the math WKT, WKT. We know that in the board exam. Especially I remember that in the board exam, I was advised. All right, no. So I don't know in today's time you guys write or not. Do you guys write this WKT? We know that. We know that. Is anybody written this? I have written many times. I've written many times. Yeah, in the 10th and 12th, I got 100 out of 100 in math. I remember using this. We know that. We know that. We know that kind of this word. This word. We know that. WKT we used to write. Sometimes we know that we will write. Have you written? Have you anybody's written here? Is it still in fashion? That's my question. When you guys write the board, especially when you guys write the board, so do you kind of write this? We know that kind of. Okay. I don't know. During our times, this was even during my engineering days. We used to write that. Anytime you write a formula, we know that we used to write, right? Why do we write we know that? Because the fellow who is correcting is not my teacher, right? He may not be my teacher. When you write a board exam, it is not corrected by the person who taught you. What do you mean by we know that? I know, you also know. That is the point. That's the point. We know that courtesy. We know that from the Fermat's theorem. What if the fellow the other side of the spectrum doesn't know that? I don't know what is this Fermat theorem. Then we will not get marks. Therefore, in the board, our teacher said that whenever you write, you know that when your teachers don't correct it, you always write we know that. Take the other person into confidence, saying that not only I know, boss, you also know from the other side. So you take them into confidence. That is what advice. I don't know. In today's world, I don't know how it works. So that is the courtesy. Basically, we know, which means I know and you know, therefore give me full marks for it. Kind of. That's what it was. Okay. You don't have to use we know. You should already, when it comes to objective papers, you just can say that I know. That's enough, because you just have to mark the answer there in the objective paper. Nobody is going to look at your steps, right? Yeah. So therefore already when you look at an RC, you look at a passage, you look at a parajumble, whatever you look, you always say that I know this, I know how to go about this, I know that. That's how you kind of start there. What you know, whenever you look at this, look at the divisor first, prime number. Look at the divisor, it's a prime number. Look at this, alright, then open up to the base, look at the two, alright, that's how you open. Are these two fellows co-primes to each other? Because every time you look at a number, alright, you are actually alright, you are actually trying to process something there, right? Okay, you looked at this prime number, one step done. You looked at this two, base of that particular 2 raised to power 100. Are these two co-primes to each other? Yes, they are co-primes to each other. But what does your theorem say? It says that raise it to the power 18, it will become 1. It has no idea about this 100. You raise it to power 100, what it becomes. Theorem has no idea about it. Theorem says that if this is 19, if this is these two are co-primes, you write 18 here, remainder 1 is definite. That is for sure. You raise it to the power 18, the remainder becomes 1. That much it comes. Okay, now I go to the isolation technique, what we learned yesterday. I'll go for the isolation technique. What is isolation technique? I will take this 2 raised to power 100. I will make them into the pieces. I will isolate them. Isolate them into what? 2 raised to power 18 one times, 2 raised to power 18 two times, right? 2 raised to power 18 three times, 4 times, and 5 times. All right, 2 raised to power 18, 18, 18, 18, like this I will do. And then finally I will write 2 raised to power 10. I will write this, all right, 18 into 5, 90. Then I will write another 2 raised to power 10 here. Fair enough. All right, so this is good. Now what author said that divide this by 19. I will divide each piece by 19. What is this? Isolation technique. Isolation, you give a big number. I know what is my standard. My standard is 2 raised to power 18 by 19 gives me 1 as the remainder. I will divide them like this. I will do this. Hey, what is the remainder here? Courtesy Fermat's theorem. This remainder is 1. I will use this remainder because it is 1. So what is this remainder here? 1. What is the sign between them? Into. Therefore, you are simply writing 1, 1, 1. So all of them you are multiplying. All you got to do is what? Only this value. What is 2 raised to power 10? It is 1024. 1024, divide this by 19, get the answer manually, which becomes your kind of answer there. Okay, this is what this is what you do in the 11th standard. The steps look more or less like this, right? You write it by saying that we know that. By Fermat's theorem, you write the theorem, you write this bit. Then you will make this isolation technique. You divide this 2 power 100 into the pieces of 18, many pieces of 18. Then finally you say that, hey, lastly something is left. I got 5 pieces of 18, but then 2 power 10 is left. You know the value of 2 power 10, 1024. 1024, you divide this by 19 and you will finally write the answer. Okay, did you understand how do we use the Fermat's theorem? We will refine this. We will refine this thought. Of course, we will refine this thought. Do we write so much? Of course not. Of course not. But you got the bottom line. Did you understand the background? Quick, understood the background. If you want the answer, please calculate 1024 by 19. Please calculate, finish it. Right, 95 and then you will get 74. Right, therefore 17 is the answer. Right, 17 is the answer. If you want the final answer, 17. No big deal about it. Calculation is no big deal. All of you know how to multiply, divide by 19. We'll get the answer. That's not the worry. But did you get the bottom line? Did you get the undercurrent here? What is that we are trying to say? That's important there. Right? Okay. Good, very good, very good. Now let's understand this. How do we write this? How do we shorten this? Should we have to write so much? Of course not. Listen to me very clearly. Listen to me. So we have to already know. So how do we proceed on this? Because nobody is giving marks for the steps here. So therefore, I don't have to really write so much and show it to anyone. So therefore, what do I do? So this is what you do. Now listen to this. You look at a question like this. 2 raised to power 100 by 19. What is the remainder? Check here itself. Check number 1. Alright, he is 19, a prime number. Check it in your mind only, you check it. Yes, this is tick. Or these two co-primes, tick. Now what you do is, hey, if it is a 19, every cycle of 18, remember, if it is 19, we know this, right? 2 raised to power 18 by 19, the remainder is 1, which means every cycle of 18 gives me 1 remainder. All you got to do is what? Remove the cycles, go here, remove the cycles, remove all cycles of 18 and check what is that which is left, which means 2 raised to power remainder divided by 19. Remainder for what? Remainder when 100 is divided by 18. This remainder. When 100 is divided by 18. That's all you got to do. Take this 100, divide this by 18. The remainder is 10. Use that here. Therefore, this question is as good as writing 2 raised to power 10 divided by 19. Your next step is 1024 divided by 19. Your next step is 17. This is how the working looks. This is all the working which looks in your mind. You may say that no, sir, some part of it I will do it in the mind itself. Do it. No, doesn't matter. Even if you want to do a little bit of it, this is all the little bit of it that you kind of write there. Is it making sense? Clear about this? This is the writing pattern. Hereafter, we will write like this. Hereafter, we will write like this because this is what the theorem which we will know. And this is how we are going to apply this. Comfortable? Are we ready to go to the applications now? All comfortable? Anything if I were to explain, let me know. I will explain. Right? Because this is the theorem. That's it. This is the theorem. This is how we represent that particular theorem. What do you mean by number is higher? Fermat's theorem, let them use any number. How does it matter? They will use some prime number. Let them use. And whatever we discussed yesterday, what is 7 there? Nikhilesh, what if the number is higher and you are saying that like 7? 7 what? What is like 7? 7 appears to be a small number to me. It's not big. We'll come to it. Just hang on. No. Okay, I understood. 7 raised to power 100. This is what you get. Hang on, hang on. Why do you hurry? Is this the first video you are watching mine? Do I leave it at 2 and then I say that well, lecture is over? Do I ever do that? You know me, right? So hang on, just hang on. Why you are impatient? Why you are impatient? Just hang on. Don't be impatient. Yeah, just hang on there. So this is a beginning. I'm just setting the foundation, and you are asking all the curious questions in the foundation itself. So this you will do only if you are watching my first lecture. If you have seen it, I will take end to end. You don't have to worry about it, right? Yeah, you don't have to worry about it. I am not only teaching this. I know what is the goal post, right? I will take you towards the goal post. I will not leave in between there. That's not the idea of taking a concept. That's not how I do the concept. Fair enough. Let's come here. This was the homework, right? Okay, let's come here. All right, let's come here. Right, this is the sum of the exam question. Look, all are CAT replica questions, my friends. All the questions that you do are kind of CAT replica questions, nothing very different there. All right, let's take a look. 59 raised to power 100 when divided by 19. What is the remainder? Firstly, the previous lecture, whatever you learned is all true. So what is the author is asking? First, you divide 159 by 19. That is the first step. When this is how the CAT gives, they will give 59 only, because they will look at that. Half the students will think that I don't even know what to square this particular number, because they forgot the methods how to do that, right? So some people will be there, 59 square only, I don't know what I will do with this 100. That's how the people think. Fair enough, let them think. But yesterday's lecture, we already understood. First, what did we say here? Hey, if it is a raised to power b divided by d, we said that your a should be less than divisor. That's a point there. First, let's do that hygiene factors first. That is the hygiene factor. I will look at 59. I'll divide by 19. 19 three times. We all at 19 three times. 57. Therefore, you are left with 2. This question is as good as writing 2. All right, now 59 raised to power 19. The remainder is 2. 59 by 19, remainder is 2. But author said that please raise it to power 100. Okay. If you raise this to the power 100, then this also you should raise this to the power 100. This also you got to raise it to the power 100. So now again you got to divide this by 19. Already you got to divide this particular number by 19. Same as the previous question. This question would now become the same as the previous question. Isn't it the previous question what we did? What is the answer here? What is the answer here? Previous question, same as the previous question. This is exactly the previous question what I worked. This is exactly the previous question. 2 raised to power 100 divided by 19. Ditto as the previous question. Right? Yeah, answer is what? 17. I already showed you that. I don't have to show this, which means earlier question, whatever I gave, 2 raised to power 100 by 19, don't expect them to give like this. This is very pleasing way of giving. 2, nice number, 2 square, 2 cube, 2 power 4. No, they don't please you like that. They kind of like trouble our mind little bit. They'll say that I will give 59. Respond to it. It is as good as 2 raised to power 100 only, but the presentation changes. Are you all learning something clear here? Clear? Same as the previous question, but this is how the presentation would come hereafter. Presentation is always different. Be mindful. Yeah, you may say that. Okay, in some exams, like okay, some exams, or you may say, sir, snap I will write. Yeah, snap they will give 2 only. That's enough for them. Snap they will give 2 only. That's good enough. That concept is good enough for snap. Not for IIM Ahmedabad. Okay, good. All right. Fair enough. All right, let's take a look at this. 50 raised to power 56 divided by 23. Okay, you might have got some idea. Get started, get started, get started. Get started quickly. Start writing something. Small pieces. Start writing. Okay, you got the starting point. Okay, listen to me. Okay, now you will say that first you will take 150, you will divide this by 23, you would say that the remainder is 4. 23 2 times 46. But author said that, hey, this is 56, man. All right, I will also write this as 56. I will write this as 23. I will check, is this the prime number? Yes. Are these two fellows co-prime to each other? Yes. All right. So now what I will do, so I will divide this by 23, 23, 23, all at 46. 10 will be left. Fair enough. So you can also do it like this. Listen to me. Whenever you have this, if you want far more better control, write this as 2 raised to power 112. That is also okay. You can write this as 2 raised to power 112. Why? You have 4 raised to power 56. This is nothing but 2 square raised to power 56, which can also be written as 2 raised to power 112. Absolutely no problem. There is absolutely no problem like this. Can I think like this? Yeah, you should. You should, because simpler the number, faster, efficient it becomes, right? Less errors. Errors will be less. quicker in thinking. Therefore, all right, if you want to think 4 can be written as 2 square. Therefore, you can 4 raised to power 56 can be written as 2 raised to power 112 divided by 23. All right. If 23 is a prime number, what cycles I should remove? Remove the cycles of 22. Start removing the cycles of 22. All right, so start removing the 20 cycles of 22. 22 into 5, 110 is gone. Therefore, this is as good as writing 2 raised to power 2. What is 2 raised to power 2? Which is nothing but 4. Why? What did you do here? 22 into 5 is 110. Remove 110 out of 112. What is that you are left with? 22. Why? Because you know that 2 raised to power 22 by 23, the remainder is 1. Therefore, you decided to remove all the cycles of 22. From here, that is also fine. What I'm trying to say, simplify the numbers. You have a 4. 4 is still a better number. Sometimes you will have not 4 kind of number. 27 you will have. If it is 27, write it as 3 cube. Write it as 3 cube so that you will get a far better control on that. That is it. That's all the small minor adjustments you should do so that it brings out some speed and accuracy. All right. Yeah, I think this question should be simpler. It's clear to all of you. Shall we go further? This is clear. Any doubts anywhere? Anybody wants to ask anything here? All clear? All clear. You are getting used to the writing style. How we are kind of writing it. The style is clear. Clear. The way we are representing it is clear. It is not confusing. Okay, what numbers we are writing, why you are writing. Is this all clear what we are writing? How we are writing? Quickly confirm, guys. Move your fingers. Okay, well, you can't get it wrong. Even with 2 also, you will get the same answer. Right? So why you will get it wrong? So that's what I said. That's what I said. Bigger the number, it will lead to errors. All right, because you are trying to handle the larger task, it will slip. For example, you try to handle a huge carton. Chances that you may drop it. Right? Assuming you are taking a small carton, easy to handle. Chances are very less that you will drop it. Yeah, you may say that out of negligence I will. That's a different issue. It's all about negligence. It's an exam when you are doing it. So you don't have that negligence. Therefore, bigger you take, it will only lead to more confusion. Therefore, I said that this is the trick I taught. Any which ways, you can still do that. 4 raised to power 56, right? To remove the cycles of 22 out of this, remove the cycles of 22. Well, then you would say that, okay, this solid no, so remove the side, 44 would be gone, right? 44 would be gone. Then you got to take it as 4 raised to power 12 divided by 23. You've got to do 4 raised to power 12. If you have taken some other power, then it may not work. Now, coming to the 4 raised to power 12, you can simply say that, okay, so you can take, all right, you can take 4 raised to power 5 into 4 raised to power 5 into 4 raised to power 2, because 4 raised to power 5 is 1024. Try to divide this by 23. This is also 1024. Try to divide this by 23. Figure out the remainders. Figure out the remainders. This is 16. 16 by 23 is this. This is how you got to handle, because you wanted to complicate the question. Complicate it. Something like this. Something like this. This is what you end up doing. Okay, making sense? Making sense? Yeah, you got to take one of these 1024 and divide 23 by 23, and you got to do it, because if you simplify it, you would have got it smaller. All right, you would have got it smaller. Like this, break it, no? Break it. At least learn to break it. If this did not occur, all right, no, breaking this here itself only, it should occur. After writing this, you, instead of breaking it like this, why not break it like this? This is all the small ideas that you got to learn, and that's what I'm teaching here. All right, now why not break this as 2 square raised to power 12 divided by 23? Therefore, from here you will say that 2 raised to power 24 divided by 23. Remove another cycle of 22 out of this. Therefore, this will become 2 raised to power 2. Answer is 4. This is what thinking you got to learn. That is what the experience should teach. Right? You got to create this experience. So that's what I'm trying to do. Why I'm doing different kind of question. So that whatever the time I get, I will try to cover as much as I could. Right? As much as I could. Otherwise, I can take the same kind of question and just do some time pass. That's also possible. Right? That's not the idea. All right, yeah. First of all, I can't cover everything. So whatever is possible in the limited thing, all right, that's what I'm trying to do. Let's create that effectiveness. Therefore, learn. This is how you got to think, learn. Higher, bigger the task, chances of making a mistake is higher. Therefore, I said that you got to write like that. Fair enough. Take a look at this question, guys. Take a look at this particular question. How do we proceed with this particular question? Quickly think. 30 seconds I will give. I'm not expecting an answer. Think, how do you proceed? Thinking, only thinking pattern. Yeah. Okay, good. All right, just opening thought. Opening thought is enough for me. Just how do you open this particular thought? As we go along, I will give more time. All right, so you take 144. 44 divided by 23, you will get a huge remainder. Rather, you write the negative remainder as minus 2. So we talked about, I told in the last class, 1 minus 1 is fine. But then I told at the beginning of the class that 2 minus 2 is also fine, 3 minus 3 is also fine, 4 minus 4 is also fine, 5 minus 5 is also fine. A lot of questions can be solved without knowing these theorems by being in control of these parameters. This itself is good enough to solve them, most of the questions, but I didn't get time to show all of this. We did only 1 and minus 1. So now, now a part of that, you can use that particular study. 44 divided by 23, you can write it as minus 2. Rather than writing 21, 21 appears to be a bigger number. You will not know beyond 21 square. 21 square is max that you might know. 21 cube also, it's people might not know. Therefore, write it as minus 2. Fair enough. Raised to power what? 115. Therefore, you are raising this also to the power 115. All right, so this is what you are kind of ending up with. All right, so what is the value of this? So here you may say that minus of, you can keep that minus outside. 2 raised to power 115 divided by 23. Keep that minus sign outside. Don't bother about it. Keep that minus sign outside and do this particular portion. Divide each, how many, what cycles I should remove? Remove the cycles of 22. 110 is gone. Therefore, you are saying that, hey, this is nothing but minus of 2 raised to power 5 divided by 23. 2 raised to power 5 divided by 23. 32 divided by 23, all right, which is nothing but minus 9. All right, that is what you write. Here it is going to be 9 and 9. 2 raised to power 5, 32. 32 divided by 23, 9. But it is minus 9 because there is a minus sign which was coming outside because the power was odd. Fair enough. Don't give the minus answer. Do what? Add the divisor back. Add the divisor back because you can't give me a negative remainder as the answer. Therefore, add the divisor back and give the answer as 14, which becomes the answer here. Making sense? Everybody clear here? Everybody clear? Everybody clear? Is it making sense to everyone? It can become negative also. Don't bother. If it is negative, keep that fellow outside, make it positive towards the end. All this drama will happen. This minus things will come, all that will come. But don't take 21. No point taking 21 raised to power 115 by 23. You will not be in control by writing 21. All right. If you write 21, the 21 square is the utmost you know. Whereas with the respect to 2, you will know much more. 2, 3, 4, 5, you will have far more control. So always take that control. Most of the questions in the exam would be designed to give you that control. Now, we take that control or not is up to us. Do we know the method to take the control is up to us. So we take or we don't take is up to us there, right? But that is how the questions would be designed more often than not. That's what the design of the questions is. All right. Okay. Are you guys learning something? Making sense here? Making sense? Is this clear to everybody? What is that 4 raised to power 22 bracket 22 Shashwat? What is that you are trying to ask? Yeah, okay. Cat question. Do this. Everybody do this and get me the correct answer. Simple cat question. Simple cat question. Everybody do this. Then we will open up to the next part of learning. Everybody do this question and give me the answer. Give me the right answer. Hmm. All right, good, good. Yeah, break it. Very good, very good, very good. Yeah, perfect. Right, 3 raised to power 5, 5, 5, 5 by 7. What is the remainder? Plus 4 raised to power all these 2's by 7. What is the remainder? Two parts. All right, you will break this question into two parts. Remove the cycles of 6 because 7 is the prime number and 3 and 7 are co-primes to each other. Right, therefore you would say that okay, I will simply divide by 6. Once you divide by 6, you would have 5 as the remainder. Right, you will get 3 raised to power 5 by 7. What is 3 raised to power 5? 243. Therefore 243 by 7, you get 21, and then you have 33. Right, you get minus 5 as the remainder or minus 2 as the remainder. This is the sequence of steps. You get 5. This is the remainder of the first portion. Similarly, I remove the cycles of 6, you will get 4 square divided by 7, all it, which is nothing but 16 divided by 7. The remainder has become 2. Fair enough. So what is the net remainder? The net remainder has become 7. 7 divided by 7, the overall answer becomes 0. Very good. Very, very good. Answer is 0 there. Pretty simple question. So all you got to remove is the cycles of 6. Remove the cycles of 6. You'll get the answer as 0. Why you guys are typing different numbers there? Yash, you are putting 5, F of ra 6. Why calculation mistakes? So many, some of you are putting 1, 5. Why? Why? Remainder has to be less than divisor. What is the confusion here? Huh? So I expect that everybody puts the right answer, guys. After doing all this, a simple cat question, if we cannot solve, then what is the study for? Tell me. Yeah. So you got to be mindful. You got to be mindful. Don't do so many mistakes. And you got all kind of numbers. There is a 1 as the answer. There is a 6 as the answer. 7 as the answer. 5 as the answer. No. Right? Okay. Good. All right. So here comes a beautiful question. Here comes a beautiful question. I want you to think about this question for 1 minute. Whether you answer or not is a different issue, right? Whether you answer or not is a different issue. Think for 1 minute. Within 1 minute, you answer or not is a different issue. But I want you to think, put some thoughts behind this. Okay, listen, I will teach you another way of doing it. You can look backward also. Listen carefully, all of you. Listen carefully. You sometimes you can look backward as well. What do you mean by looking backward? Let's learn this. Let's learn this. Sometimes you can look backward as well. Call it for better efficiency. Listen, everybody, listen here. What do you mean by looking backward? 71. So first we will take 171. Listen, forward is anyway we know. We already know how to do it forward. Let me quickly tell you how to do backward as well. 71 when divided by 17, we know that the remainder is 3. 17 into 4, 68. Therefore, it is 3. So, raised to power 62. Fair enough. I got to raise this to the power 62. Right? I got to raise this to the power 62. Okay. Divide by what? Divide by 70. Therefore, remove cycles of what? 16. I got to remove the cycles of 16. If you remove the cycles of 16, you would say that, okay, 16, say 16, say 16 three times. 48 you will remove because 16 four times will become 64. But look at this. 62 is very close. This 62 is very close to 64. It is close to 64 when compared with, all right, when compared on the other side with 48. Why? Cycles of 16, when you remove, you can remove up to 48, right? You can remove up to 48 and you can write this as 3 raised to power 14 by 17. That is one way of writing. What is the another way of writing? Listen to me very carefully, right? We know that 3 raised to power 64 when divided by 17, the remainder is 1 because you got to remove the cycles of 16 from there. Right, you will be removing the cycles of 16 from there. So 3 raised to power 64. This is the caption. 3 raised to power 64 when divided by 17, the remainder is 1. But it is 62. I'm very, very close. What I do? So I will take this, I will rewrite this. Okay, I know that the remainder is nothing but 1 for this. But 3 raised to power 64 can be written as 3 raised to power 62 into 3 raised to power 2. You may wonder, sir, why 62? Because that is what you wanted. What we want is 3 raised to power 62. All right, 3 raised to power 62 by 17, this also by 17. Why? Because 3 raised to power 64 should be divided by 17. Do that, 62 on this. Okay, I don't know what is the remainder for this function. I will get some remainder here and I will be getting some other remainder here. This remainder, do I know? Yes, it is 9. What is the remainder here? I don't know. It is k. What I am dividing by? 17. What is my remainder? 1. So what is that? This remainder is 1. What is the output? Hey, 3 raised to power 64 when divided by 17. What is the remainder? Okay, let me rewrite this once again, because you got to understand this. Once you understand this, your outcome will be very, very faster. Listen to me. 3 raised to power, we know that 3 raised to power 64 when divided by 17, the remainder is 1. Why? Because cycles of 16, all cycles of 16 gives me 1. Fair enough. Now look at that. Output don't change. Don't change the output, because the input also I'm not changing. I'm rewriting the input. What is the 3 raised to power 64? I'm writing it as 3 raised to power 62 into 3 raised to power 2 divided by 17. The remainder is 1. I didn't change anything. It is 64. Now also it is 64 only. I didn't change anything. Therefore, my output will not change. Okay, fair enough. Now what I will do, so my method of isolation, 3 raised to power 62 by 17 gives me one remainder. 3 raised to power 2 by 17 gives me another remainder. What should be the net effect? The net effect should be 1. The net effect has to be 1. All right, fair enough. Okay, what is the effect on this? Effect on this is 9. 3 square is 9. 9 divided by 17, remainder is 9 only, right? 9 divided by 17, remainder is 9. Okay, what is the remainder here? I don't know. Remainder here is going to be k or r, whatever you want to write, you write it, doesn't matter. 3 raised to power 62 when divided by 17, I'm expecting a remainder called as k. Okay, therefore 9k should be 9k when divided by 17, the remainder should be 1. That's it. That's all you are trying to say. 9k when divided by 17, the remainder should be 1. Very simple. That's all I'm asking you here. Therefore, what is the smallest value k can take? You tell me, guys, what is the smallest value k can take? 2. 9 into 2 when divided by 17, the remainder is going to be 1. Therefore, what is the value of k? Well, because you said that 9 into 2 gives you 1. Therefore, the value of k is nothing but 2. Simple question. All right, very, very simple question. Very, very simple question. 2 is the answer. 2 is the answer for this particular question. 2 is the answer for this question. Everyone, clear about this? Clear? Did you get this? Backward. How to attack it backward? Because if you want to go forward, all right, now it was becoming 14. 3 power 14 is a big number. 3 power 14 becomes a big number. Instead, come backward. Come backward. Attack it backward, because 62 is very, very close to 64. You go with 64, then break it. Then break it and then work with that breakage. This is another method. This is important. This is important, because sometimes the cat asks the question, look backward, because looking forward is painful sometimes. Look backward, you'll get the answer faster. Comfortable. Otherwise, you are supposed to manipulate 3 raised to power 14. You are supposed to manipulate, because now the theorem will not work for 3 raised to power 14. You got to break it. Break it. 3 raised to power 14. You will break it into 3 raised to power 5, 5 and 4, and then you will mix them together. It will take a little longer time. But if you look backward, it will take shorter time. Are you understanding my message? I'm crying my lungs out. Are you understanding it from the other side? Or am I simply crying here? Crying means shouting. Yeah, I'm not shouting from the bad intention. I'm saying that, okay, I'm putting that much effort to explain. Because sometimes to teach the deeper content, it drains out the energy. Right? But I love it. I love it. I love to teach the deeper content for a simple reason that it drains the energy. All right, I've seen a lot of my colleagues as well. A lot of my colleagues as well. So we used to discuss, hey, today I will teach very light. All right, sometimes they used to tell light. Why? Because teaching depth will also drains out the energy. It drains out the energy from either side, right? Either side. It drains my energy, it drains your energy to absorb it. It drains from either side. But that's fun. That's fun. I really enjoy it. I enjoy that. That's always the fun. Right? Yeah. Okay. So I hope all of you are getting this part. Good. Very good. Very, very good. All right. So here comes another one. You try this now. You try this. Very similar to the previous question. Try it out, my friends. Try it out. Faster. You can try either ways. Forward is also fine, backward is also fine. Whatever is comfortable to you. I taught both the methods. Both methods are known, choice is yours. There is no hard and fast rule that you should do like this, like that. I taught both the approaches. Yeah, okay. 55, let me do it. 55 divided by 19, the remainder is minus 2. Right, minus 2. But author said that it is not 55, man, it is 15 5 raised to power 104. Then this should become minus 2 raised to power 104 divided by 19. Minus 2 raised to even power becomes 2 only. Therefore, this question is as good as 2 raised to power 104 by 19. Author said 55 raised to power 104. Tell me the remainder. It is as good as 2 raised to power 104 by 19. Okay. So I got to remove the cycles of 18, right? I got to remove the cycles of 18. 108 is a cycle of this. So we know that, hey, had it been 2 raised to power 108, see two parts. I can do go up to 2 raised to power 19. 2 raised to power 104 lies between. 2 raised to power 104 lies between 2 raised to power 90 and 2 raised to power 108. Why 90 and 108? Both are multiples of 16. Why I'm looking at 90? Because it's a multiple of 18. Why I'm looking at 108? Because this is also multiple of 18. I would rather see that, hey, I relate it better. So I would say that 104 is very close to 108. Therefore, I would rather look at it backward. I'm fine. You may say that no, sir. I will go from 90 to 104. 2 is a small number. Absolutely fine. I taught you both methods. Which way you want to do it? There is no hard and fast rule. It is your comfort level. Do whatever way you want to do it. But if this base number is big, it is wise to go backward. 2 3 are still fine sometimes. Okay, yeah, fair enough, any which way. Therefore, I will start here. I will start by writing that, hey, 2 raised to power 108 when divided by 19, the remainder is 1. We know this. Let courtesy Fermat's theorem. By using the Fermat's theorem, we get this. Okay, but author wants 104. He is not interested in 108. Okay, therefore I will rewrite this. I will say that this is 2 raised to power 104 into 2 raised to power. Okay, divide by 19. Therefore 2 raised to power 4 divided by 19. The remainder should be equal to 1. All right. Okay. So this remainder I can find it. This is nothing but 16. You can write minus 3 also, write whatever you want. Doesn't matter. Okay, 16 here because you will know the tables of 16. Therefore there should not be a problem. And here, what will be the remainder on this particular side? I don't know. Remainder here is going to be R. That is what the answer, what is required there. This bracket implies it is R. 16 times of R when divided by 19, the remainder should become 1. Okay. So therefore, what should be the value of R? Start with this. Go by the tables of 16. 16 ones are 16. Put R is equal to 1. 16 ones are 16. 16 by 19, is it 1? No. Change it to 16 2 times 32. 32 divided by 19 is the remainder 1. No. Like that, when you do it, you understand that for a value of 6, it works. 16 into 6, 96. 96 divided by 19, the remainder is 1. Because 19 fives are 95. Therefore, the remainder becomes 1. So, and hence you got the value of R is equal to 6. That is the required answer. 6 is the required answer. Right, that is looking backward. You may say that no, sir, 2 is a small number. I will look forward. I have no issues with that. There is no issue. I am only teaching both sides because sometimes when the numbers are cumbersome, instead of getting a 2 here, had I got 7 there, etc., it doesn't make sense to calculate 7, or let 7 raised to power 90 to 4, 104. It would rather made better sense to go backward there. It would have made better sense to go backward there. That's what we kind of do. Is this clear to you? Everyone clear? All clear? That's correct, Shashwat. What you wrote is right. What you wrote is right. Absolutely. That is what I'm trying to tell. What you have written there is right. Yeah. Hmm. That's right. Hmm. Okay, my question here. Can we apply Fermat's theorem on this question? Can we apply Fermat's theorem on this question? 91 raised to power 37 when divided by 65. Can we apply the Fermat's theorem? Do you think we can apply the Fermat's theorem on this? Right. Hmm. Very good. They are not co-primes. HCF is 13. Very good. Very good. Reasons are also very good. Very good. Good reasons. Good reasons. Now listen. Everybody listen here. Right? Everybody listen here. Correct. Correct, Kalyan. Everybody is right. Everybody is right. Your understanding is correct. Right? Now, this is on the face of it. Listen to me. Now, no theorem can be applied. Right? If we go with that understanding, tomorrow I will teach you, say, for example, Euler's theorem. So you look at the Euler's theorem, that also will not work on this, right? None of the theorems will work. Then this is a kind of CAT model, what I'm doing here. Again, another CAT model. Then what do we do? All right, now 65 is also large number, 91 is also large number. Correct. That is what we do there, right? So how do we go about this? Now we do FPA. Whenever you have a composite divisor, any composite number n can be resolved into primes. Any composite number n, any composite natural number can be resolved into primes. Right now, this is called as fundamental principle of arithmetic, FPA. Right? Okay, you may say that no, sir, my NCRT book called by some other name. Whatever principle your NCRT book called, please take that principle only. I call it as FPA because the books I read call it as the fundamental principle of arithmetic. It says that any composite number n can be resolved into primes. That is all it says. What does it mean here? For example, if I have a number called 12, it can be resolved into 2 power 2 into 3 power 1. It is resolving into primes. That's all I'm trying to say. Hey, what if I have some number like 72? You can write this as 2 raised to power 3 into 3 raised to power 2. So these are the primes. Prime number 2 has been considered 3 times. Prime number 2 has been considered thrice. Prime number 3 has been considered twice. This is called as fundamental principle of arithmetic. Okay, if your teachers might have given a different name, there are 2-3 names by which people call it. Because I've dealt with the students and suddenly in the class one fellow will raise his hand and say that, sir, this is also called like that. This happened. Yeah, so therefore your teachers have given a different name to it. Please go by that. I have no problem. So whole idea is what? A composite number n can be resolved into primes. That's the whole point there. Fair enough. So what I should do whenever the divisor is a composite number, because so far we dealt with prime number. Whenever the divisor is a composite number, first we will resolve it into primes. Divisor, not the number. Not the number. I'm never interested in the number because I said that first look is always the divisor, and then you look at the base, and then you look at the power. This is the sequence of looking at the question. Not whichever way I like, I will start seeing it. Hey, I will look at this. All right, now 91 came first in the question. While I was reading from this side, this comes first. I will stop there for a while to. No, you don't do all that. You will always look, where is my divisor? Where is my divisor? What that fellow is trying to do. Your divisor is either going to be prime or going to be composite. Now I'm telling that what if it's a composite? If it is a composite, resolve it into prime first. All right. So what is this 65? Therefore, you would say something like this. Therefore, you say that this is 91 raised to power 37 divided by 13 into 5. You resolve it into primes. So what did I do? I took this 65, I resolved this into primes. That is the first step. Any question for that matter. The moment you find a composite divisor, hereafter, you will simply resolve it into primes and check what is my divisor made up of if it is not prime. That is the very fundamental thought in remainders. That's a very fundamental thought. Fair enough. Having understood this, let's be clear, because I'm not going to tell this time and again. You got to apply this FPA on the divisor first. Okay. Now you find that this 13 is what was common between the two. Now what you do, put this fellow like this. So you say that 91 raised to power 37 can be written as 13 into 7 raised to power 37. That's my number. And I have 13 into 5. Now listen very carefully. What I do, I will keep 13 outside. I will just keep 113 outside. I will say that, hey guys, you guys, both of you stay away. Right? Both of you stay away, equal, right? There is 113 here and there is 113 here. You both of you stay away. So inside the bracket, you will say that 13 raised to power 36 into 7 raised to power 36 divided by 37, 7 raised to power 37 divided by 5. So I didn't do anything. I said that, hey, there is a parity. You have a 13, I have a 13. So the divisor says that I have a 13, you have a 13. Let us keep it outside. Let us keep it outside. Don't keep 13 raised to power 37 outside. It's a 13 raised to power 37, 13 raised to power 37, 7 raised to power 37. Only 113 you keep it outside. All right, I kept 113 outside. Therefore, inside I have this. Now look at this. Hey, are they now? 5 is the divisor. Now 13, is it co-prime to it? Beautiful, it is. 5 is the divisor. Is 7 co-prime to it? Yes, of course it is. Therefore, now I say that I will apply the Fermat's theorem on the square bracket. I'm looking at the square bracket. Here is where I'm going to apply the Fermat's theorem. What about the 13? Keep it out. Keep it out. Tell them that, friends, wait till I finish my Fermat's theorem. Now come back to this. Now let's work on the Fermat's theorem into this. Now I'm highlighting this portion. What is that? 13 raised to power 36 by 5. Isolation technique, divide and rule, right? Into 7 raised to power 37 divided by 5. This is nothing but, this is nothing but 2 raised to power 36 by 5. You may say that why 2, sir? So because when 113 is divided by 5, in your mind, the remainder is minus 2. So 313 raised to power 36 minus 2 raised to power 36, nothing but 2 raised to power 36. Therefore, the remainder is solid. Now you divide this by 4, you divide this by 4, remainder is 1. Courtesy Fermat's theorem, remainder is 1. Now 7 raised to power 37 is as good as writing 2 raised to power 37 divided by 5. Remove the multiples of 4 here, cycles of 4, Fermat's theorem. Therefore, the remainder has become 2. Now listen to me. You are now saying that the remainder is, now listen to this. I am coming back to this story. I applied Fermat's theorem. This 13 is outside. This 13 is outside. Now you said that, hey, my remainder has become 1 into 2, 2. All right. Remainder is 2 when the number was divided by 5. I applied the Fermat's theorem. I came back to them. Friends, I'm back here. That's what I'm trying to tell them. 13 and this. Hey, what was your divisor? Your divisor is 65. 13 into 5. What is the divisor you have in the bracket? 5. Then what you do? Bring this fellow back into it. Bring this fellow also back into it. 13 into 2, you call it as 26. 13 into 5, you call it as 65. Now what is this here? This itself is the remainder. Is 26 less than 65? Yes. Therefore 26 becomes the remainder. Where did I teach this yesterday? Listen to me. Yesterday I taught you like this. When the number is divided by the divisor, if it leaves the remainder r, then I told you yesterday that when k times, all right, when k times of the number, all right, this is my number, k times of the number is divided by k times of the divisor, it leaves k times of the remainder. This is what I taught you yesterday. K and k will not get cancelled. That is what I told you yesterday very clearly. This was my k, this was my k, this 13 was my k. I told my friends, you be outside, I am not cancelling you. You be outside for some time, otherwise you are creating a trouble to me to apply the theorem. You stay outside. Once you stay outside, I will come back and give the remainder. Hey, what was my number here? This was my number. Listen to this. All right, I will do this. All right, now what was the number? This was this particular circle. What I'm circling is, this is my number. What is the number? 13 raised to power 36 into 7 raised to power 37. When divided by 5, the remainder is 2. All right, 2 into 1 here, 2 into 1, remainder is 2. But what you are saying here, you said that, sir, this 13 was outside, right? Correct, come back. Therefore, 13 times of this number divided by this 13 was outside, 13 times of the divisor, nothing but 65. What should be your answer? 13 times of the remainder. This is what precisely I did. Clear about this? Everybody clear on this? Everybody clear what we did? That's right, Mr. FFR. Rule number 4, that's correct. Whatever, 4, 5, whatever the sequence numbers you have given, this is what it is. This is what happens on the, this is what happens. All right, this is what happens on the Fermat's theorem at the highest level. Now, I'm not saying highest level, next level, because highest level still exists. I'm not touching level 3 there. Yeah, this is what happens on the Fermat's theorem at the next level. Did you guys got of idea? Got the idea here? Everyone clear about this? Everyone clear on this, what we did? Right? Yeah. I applied this rule. Yesterday, somebody was asking how to apply this rule. What is this particular rule? That's what I showed you here. Hmm. Okay. Right. All right. All right. Very good. All right. So now you do a cat question. Do this cat question. Do this cat question. 23 raised to power 19 plus 19 raised to power 23 divided by 23 into 19. What is the remainder? Cat question. Yeah, solve. Everybody solve. It shouldn't take more than a minute. Honestly, it should not take more than a minute. Rishav, as a matter of practice, we have to complete that question. That's it. That's a complete thought of thinking. You cannot change your divisor, right? Okay. That's how you think. It's not about I do only numerator, I do only number, I don't do divisor. It's not about that. It's about how do you keep it out. Do this cat question, you will understand why you should. See, once you understand, all these questions can be done mentally. This is a mental math, right? Yeah. Yeah. We should do both because we are not supposed to change the divisor as well. Okay, isolate and do it. Very good, very good, very similar. All right, very similar to what we discussed before. 23 raised to power 19 divided by 23 into 19. One side of the problem. Second side of the problem, 19 raised to power 23 divided by 23 into 19. Two types of the problem. Let me tackle the left hand side of the problem. Okay. So again, keep 123 outside. You cannot cancel. It's a division. You cannot cancel. Keep the 23 outside. So therefore 23 raised to power 18 divided by 19. This is the Fermat's theorem as it is. Remainder is 1. This remainder becomes 1. Remainder becomes 1 because you kept 23 outside. Multiply this by 23. Therefore this becomes 23. Similarly, do it on this particular side. You will get 19 from here. Right? Therefore, your overall answer becomes 42. Is this number 42 less than 23 into 19? Of course, yes. 42 is less than 23 into 19. Therefore, this becomes your answer. This is Fermat's theorem as it is. This is Fermat's theorem as it is. When 23 is divided by 19 raised to the power 18, the remainder is 1. That's what I wrote here. Remainder is 1. But since you kept 23 outside, come back and multiply by 23 because a number divided by the divisor, it has left 1 as the remainder. What was the number here? The number was 23 raised to power 18. What was the divisor? 19. But what did you do? You kept a 23 outside. Therefore, 23 times of the number divided by 23 times of the divisor, remainder will be 23 times. That's what I did here. I simply brought this 23, multiplied, I said that remainder is 23. Do precisely same thing on the other side, you will get 19. Therefore, your overall answer is 42. It's a mental math. All right, so you can visualize that here. Right, on this particular question, you can simply visualize and do it. No big deal about that. Okay, are you getting hang of this? Are you getting hang of this Fermat's theorem? You are getting hang of this Fermat's theorem. All clear? All clear? Right. Quick, quick, quick. You got some hang of Fermat's theorem. We discussed for almost about an hour now. So you got some hang of this. Yep. All right. So I will stop the theorem here. There is no end. We can keep talking about it, but then somewhere we need to stop, right? Somewhere we need to stop. Yeah, this is where I end this. I end my inputs for now. So I will take up another theorem every class. I just take one theorem there and I will leave it there. Okay, so tomorrow I'll be doing this algebra series on inequalities, algebra inequalities, but this would be a free special class. This you may have to download the app. If you have not downloaded, download the app. I'll be doing two lectures on inequalities, one at 11, one at 8. So it's a continuation. So you can go by, you can download the app and you can go to Cat Ninjas there. You can search, already you can search with this. Then you will kind of find it. What are the things I'm doing under inequality? What I'm doing in the morning, what I'm doing in the evening, what I'm doing in the morning, what I'm doing in the evening. You kind of understand what I'm trying to do in the morning, what I'm trying to do in the evening. Go there and book that. Already book that particular class. Once you book it, you will automatically get the notification once the lecture starts, right? Yeah. So another important thing with the app is you will also get the lecture notes, whatever the PDF that kind of I upload there, that PDF will also be transferred to you once you complete that particular lecture. While downloading the app, when it asks for a referral code, you can put this Belvi 100 and you can put that referral code. Yeah, this is what the upcoming lecture for Wednesday. Wednesday, this is the schedule. Right? Okay, therefore no YouTube lectures tomorrow. It'll be only on the application, only on the Unacademy app. Okay, if you have liked what we are discussing, press the like button before you leave, and you can also share this link with others. Let them also watch this and get benefited. So share with your friends as well. If some of your friends are also preparing, let them also watch it. Let them also come into the lecture, ask us some doubts. All that stuff would be very encouraging. Yeah. Good. All right. These are some of the batches which started in the past, just about a couple of days back. Some of them are for CAT 21. Some of them are for CAT 22. If something suits your requirements, go ahead and you can make that. So I will also be launching the plus batch. That's after 17th or 18th. I will come back to you with the details on that. Okay, that is pretty much about today. Any questions, anything that you would like to ask there, you can put quickly in the comment. I will wait for a minute. I would wait for a minute. Yeah, something that you want to put it there in the comments there, you can put that. And those who join sometime in between, watch the numbers one video also, watch this as well, so that it will be in continuation to what we will be trying to do there on the remainders. Yeah. So you can also join me in on this. You can join in on this so that you will get the class notifications, etc. in this particular Telegram group. Yes, anything, anybody? You want a question as a homework? Yeah, sure. You can take. Why not? Take this question as a homework. Okay, well, you want a homework? Take this. Yeah. All right. Fine then. Okay, no questions. All right. So I will see you guys tomorrow at 11 a.m. in the morning. Good night. So catch you there in the morning. Sleep well and get up with all the energy back. Bye bye. Good night.